I might as well get in a compliment. So.
Yeah, that frightens me.
Welcome, everybody. Sorry for the delay. I thought we were going to have a light turnout tonight and a light program, but neither of those things. Well, we've got quite a few people, and we've got a really excellent show for you tonight. We have a couple of really fascinating presentations. Hopefully, the way we've rigged things up here will carry us, and we'll see. Hopefully, we won't stumble too much there. But I'll jump right into it because actually the other thing we have is a boatload of observations. I don't think I've ever seen this many observations. I think we got 10 people that have submitted observations for this meeting. So we got a lot of interesting slides there. And without further ado, I think we'll rock and roll if Tim can advance the next slide for me.
All right. Yes, maybe I can.
Maybe you can. There. Go one more. No, go one more. That's not the one. The next one after that? After that?
All right, come on, work.
There we go. All right, so tonight's program, we've got Gary Boyle with Ottawa Skies. Al Scott's going to give us... Is Al Scott here? I hope he's here.
Yep.
Oh, wow, man. I was looking at your slides when Chris and I were putting this together. Al's going to talk to us about a highly eccentric dwarf inside Uranus. I saw that title and I thought, I'm going to leave that totally to him to touch. I'm not going anywhere with that. I'm really looking forward to what you've got to say about that, Al.
Where the sun don't shine.
That's right. Brian's going to give us a really fascinating presentation on the Titanic, since we're approaching the century mark since that great ship went down. We've got some public outreach stuff for you. And then Chuck's got a fascinating piece for us on impacts on Earth. And everybody, when we think of cosmic impacts on Earth, we think the dinosaurs getting nuked and everything else. This is something a little closer to our period of time. So looks really fascinating, Chuck. I'm looking forward to it. And like I said, we've got a pile of observations. So next one there, please. I just want to give you a brief bit on the Ottawa members in the news. Got this lovely image here. This is Tony Peterson's. He made the cover of the journal with a beautiful shot of the Pleiades. And we wanted to include his original version as well. This is just a scanned version off the print, but there's his original shot there, and we wanted to show that in all its glory. So really nice piece of work. Really nice piece of work. Yeah. That's a beautiful shot of the Pleiades.
Is Tony here tonight?
Yeah. Hope so.
How are you, Tony? Very good.
Excellent.
Was that done in town or out of town? Was that done in town?
Three different sites, three different dark sites.
Really? Awesome. How long of an exposure is that?
It's about 8 hours total.
Wow. That's deep. That's excellent. Beautiful work. All right, next one, please. Also, a bit of news here from, I remember mentioning to you the RASC had a sketching contest. And we had 2 winners of all the entries that were submitted. I don't know how many people went up there, but hopefully you had a chance to check that out because there were some really, really nice pieces of work there.
The Astro Catchers contest or something?
Oh, Chris. Okay, that's one for Chris.
At least it's not the Astro. At least it's not the Astro Catchers.
Yeah. That's what happens when you do things in a hurry, eh? So anyway, yeah, we had 2 winners, and we'll show you the 2 winners there. They shared first place there. Alexander Massey with a beautiful sketch of Aristarchus. I saw this when I went up on the site to check these sketches out. At first, I thought this was a photograph. This was it's just lovely piece of work. And second of all, also tied for first place, our own Gordon Webster with a beautiful sketch of transits across Jupiter. I think, do we have a blow-up of that? Yes, there we go. So nice piece of work. Very nice piece of work. All right, and next I think we're up with Mr. Boyle. Mr. Boyle, take it away. Oops. And don't trip over any wires. People will get mad at me.
Good evening, everyone. Talking about dwarfs. Hear that the dwarfs were all in bed feeling happy, so happy left.
That one made me grumpy.
I hope everyone had a real good month. Of course, Venus has been in the western sky blazing away. If you've been under a rock for 2 months, you probably haven't noticed, but a lot of great Kodak moments. And I'm sure a lot of the probably observations are Kodak moments with, digital moments with Venus.
Yeah, Kodak's kind of.
That's it. They're gone. They're passe. So for the next, for the first slide, we'll see what's coming up this month. The International Space Station has some pretty good passes over Ottawa. I've taken this from the Heavens Above website for Ottawa, and you'll see on the 12th of the month, coming up in there a few days. Beautiful. Minus 3.5 magnitude. Almost as bright as Venus. Venus is about 4.5, 4.7. And next slide. And we'll see the path that it takes is pretty well overhead, since being 84 degrees above. So you can see it's pretty well right overhead, right next to Orion. So it's just like a very, very bright Venus. And you'll see this is not a mistake. It actually disappears into the Earth's shadow. Pretty dramatic to see. It's going, 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 gone. Next slide. And we'll see that it's close. It's only 403 kilometers, but it's this distance from Ottawa to Toronto by the highway, not by the bird flies. Pretty well by the way the crow flies. If you want to keep in mind for time signal, because not everybody has the right time on their watch, it still is the same recording, 613-745-1576. It's a 30-second pulse of time signals. Synchronize your watch. Just use those times coming up. Next, and later on the 23rd, pretty well the same, minus 3.5. 81 degrees, which is, again, almost overhead. So 2 great opportunities. Of course, there are many great chances to see the ISS, but extremely bright conditions. Speaking about conditions, I noticed that the humidity at supper time today was 18%. I've never seen 18% humidity in Ottawa. Terrible. It was great. And you can see it just moves into the shadow a little earlier this time. Great, thanks. And there's stats again, 403 kilometers. That's pretty well, I guess, the lowest that they can get overhead. So pretty dramatic. Again, nice digital moments if it's a clear sky, especially with Orion, just that line going right through it. Try it out. Pixels are free. Next slide, please. So here we have the Ursa Major, the backward question mark. Of course, sorry, not Ursa, but Leo Major. Leo the lion with the mane and the hindquarters. Here we have Mars, beautiful orangey color. It's like we mentioned the past few months, it's the worst apparition that we've had in the last 30 years. The furthest away, it's only about 14 arc seconds across, so very, very small. But still, you can point it up to your neighbor, say, that little thing up there is Mars. And while some points, probably get a free barbecue out of it. And right next to Mars, of course, we have a nice, beautiful trio of galaxies, M95, 96, and 105. Next slide, I think, will show a nice close-up of that. Here's 95, 96, and 105, along with some other NGCs. And you'll see that this picture was done by Arnie. And you'll see over here is a little dot. Well, that dot is a supernova in M95. It's 2012 AW. And it's extremely bright. In fact, I photographed it myself the other night, and it just looks like a regular star. It's not, I think I see it, it's like, it's there. Extremely bright, so very easy to find with the trio just near Mars. Mars has moved off a little to the right, but if you've never seen a supernova, it's not Earth-shattering. Well, Earth-shattering wasn't too good if you're around the area. It was earth-shattering. Where's the kaboom?
Yeah, not my backyard.
Well, that kaboom was equal to about 500 million suns worth of energy going off. That was just an incredible supernova. Next we have, moving on to the next show. Okay, next slide. Is the other trio, beautiful trio of M65, 66, and NGC 3628. Somehow Messier didn't see the third galaxy. That's why it's just cataloged in NGC. And next slide, and then we'll show you the beautiful trio of 65, 66, and 3628. Just a fantastic trio, about 30 million light years from Earth. Just a fantastic observation in a telescope, and of course the photograph. And with digital cameras nowadays, even with a simple Canon Rebel, it's amazing what you can do with a telescope. And next slide. So if you thought that your night was going to be boring, here's the very end of Leo the Lion. These are all galaxies down to 15th magnitude. So if you think there's nothing else to look at in the sky, you'll have your work cut out for you. Hundreds of galaxies all in the Virgo cluster. So between Coma Berenices and Virgo, which stretches then all the way up to actually Ursa Major, just a real realm of galaxies. And galaxy clusters, as we've seen before, some groups and knots of galaxies. So pretty well in this area, you're pretty hard pressed to put your eyepiece, of course, in a nice dark area. You're just plank your telescopes there and you're bound to find some galaxy. Next slide. And here's the montage of planets. Moving with Mercury is just past its greatest height in the morning, greatest western elongation. Of course, Venus is the eighth sister or the visiting cousin on the third. Mars still nice and bright, and pretty bright, but we've had better. Your real last chance to see Jupiter, you'll notice that Jupiter's really moving quick toward the horizon. Saturn's up all night, and the rings are tilted to a nice 13.8 degrees. So again, get the cameras out. If not, just observation. It's pretty well something like this. That's pretty well the orientation now. And Uranus is moving close. Well, they're on top of each other, sort of thing, on the 22nd of the month. And Neptune is stuck in Aquarius, and it'll be stuck there till year 2023, because it does move only once around the sun in about 265 years. And next slide. The last slide again for the pink moon is just today. It occurred this afternoon at 3:19, because every month, according to the Farmer's Almanac, is a different moon, like the Hunter's moon, the Harvest moon. Well, this one is the pink moon for this month. And here we have for third quarter, new, which is lunation 11:05, and first quarter. So, and that should be it. Next slide, and that should be it. Yeah. So I wish you all a happy Easter. Does anyone know why Easter, Easter changes from year to year? Sometimes it's early, sometimes it's late. Great, one person. What it is you take the spring equinox, the next full moon, which is today, is the Sunday after. That's what depicts from the end of March pretty well to the end of April. So it's spring equinox, full moon, that Sunday. Great, thanks again, see you next month.
And Al Scott, who's here to tell us about eccentric dwarfs. I'm all ears.
Thanks, Paul. All right, do we have a clicker, or do we have a way to advance the slides?
Do you want to do it, or shall I?
You can go ahead, sure. So go to the first one. So as Paul has foreshadowed, there's a theme to the news this month. It's about dwarfs. So the first story is about HARPS and wobbling dwarfs. So HARPS is a European Southern Observatory instrument in Chile, which is basically measures the Doppler shift of stars. So it's looking at the spectrum of the light emitted by stars, and it's measuring the Doppler shift to try to detect planets. And so they've been doing this for about 6 years now, and they've been looking at red dwarf stars, which are the most common stars in the universe. And the reason they're choosing these is because it's easier to detect smaller planets around smaller stars because they wobble more as the planet rotates around it. You can't actually image the star from Earth, or the planet from Earth. All you can see is the star. The planet is lost in the glare from the star, but you can see the effect of the planet on the star as it goes around and pulls the epicenter of the orbiting pair backwards and forwards. So what they've been doing is over 6 years they've been studying using a 3.6 meter telescope at ESO's La Silla observation in Chile. They've been surveying a carefully chosen sample of 102 red dwarf stars in the southern skies. And what they've done is they've discovered a total of 9 super-Earths. Super-Earths are in the mass range from 1 to 10 times the mass of the Earth, orbiting these stars. And 2 were inside what's called the habitable zone of the star. In other words, they're orbiting at the distance where water would be a liquid on the surface. So that in thermal equilibrium, water would be liquid in 2 of these 9 planets that were discovered, around Gliese 581 and Gliese 667c. Now, considering the sensitivity and measurement biases, this suggests that between 28 to 95% of all red dwarf stars have super-Earth planets orbiting in the habitable zone where liquid water can exist on the surface of the planet. In addition, their data suggests that only about 12% of red dwarfs are expected to have gas giant planets like our sun. So mostly these smaller rocky worlds, and a good chunk of them are in the habitable zone, which is really an interesting discovery. As there are many red dwarf stars close to the sun, the new estimate means that there are probably about 100 super-Earth planets in the habitable zones around stars in the neighborhood of our sun at distances less than about 30 light years. So very interesting if you're following the biology or the possibility of life in the universe. This suggests that there's billions of potentially habitable planets in our galaxy just around red dwarf stars. So that's interesting. So next. So as Paul hinted, this one is about a dwarf planet that's been recently discovered, 2012 DR30. But as I learned more about this interesting discovery, it's a 200-kilometer diameter dwarf planet, but there's something interesting about it. It's highly eccentric. The orbit of this planet is very close to a parabola almost. It's 0.91 eccentricity. It's very highly elongated orbit, and apparently it's very close to its perihelion. It's closest point to the sun, and it turns out that it's just inside Uranus. So I had to.
It was your wording, Al. It was the wording.
So go to the next one. So this is a plot showing most of the bodies in the solar system on a graph. Along the bottom is a semi-major axis. That kind of gives you an idea of how far from the sun the object is most of the time. On the left upper axis, we have the inclination of the orbit. The inclination of this one is denoted by the blue circle. It's a very high inclination orbit, around almost up to 80 degrees from the plane of the solar system. So it's going in a very strange orbit. You can see most of these things are below 40 degrees inclination. Most of them are in a plane, like a disk. Well, this one's kind of shooting up. There are some other bodies in this area too. On the right side is the eccentricity. At the bottom, you have a circular orbit. At the top, you have a parabolic orbit, basically. And the green circle denotes the eccentricity of this object, very high eccentricity. The semi-major axis of this, they're not sure yet. They've only been observing it for a few months. It could be anywhere between 300 up to 1400 AU. But they're estimating then that the actual orbit of this thing could be 50,000 years. So it's an interesting thing. You can see the Kuiper belt is this mass in the middle here, right around semi-major axis of 40 AU. But an interesting discovery nonetheless, and I just had to throw it in for the title. Next.
Is it going to crash into Uranus?
Maybe.
If it's so inclined.
That was good.
Very nice.
So we've had dwarf stars, we've had dwarf planets, and now we're onto dwarf galaxies. So this is an interesting one as well. An amateur-professional collaboration has resulted in an image of a dim dwarf galaxy being swallowed by a member of our local group, NGC 4449, which is pictured in the center here. And the amateur image is in the background there. And you can basically just barely make out the dwarf galaxy that's gone through it. It's kind of a comet-shaped stream of stars. Now, NGC 4449 is about 12.5 million light years from Earth, and the image was produced by the Centurion 28-inch telescope by AstroWorks Corporation of Arizona. And the CCD was at prime focus. The galaxy 4449 is a starburst dwarf. It's forming stars very furiously. It's blue to the eye. You see the blue color from all the young stars that are being formed in it. And in fact, what astronomers think is that this dwarf galaxy smashed through the NGC galaxy, and the gas clouds in the two galaxies collided together, and they hung around in the heavier galaxy, and the smaller one got stripped of its gas and went on through. And this is possibly what triggered the starburst in the major galaxy. Now, the reason this has only been discovered recently is that the minor galaxy there is about 10 times dimmer than the sky brightness. So they had to get that background picture about 18 hours of integration to actually make it out. And in the bottom right, you can see what that stream of stars looks like using the 8.2 meter Subaru telescope. It's actually a bunch of red giant branch stars because there's no longer any gas left in the dwarf that's been eaten by NGC 4449. So interesting. A lot of people think now that there could be quite a few of these dwarf galaxies out here that are just too dim to see because they're just below the sky brightness or even dimmer. So, you know, if you can look for starburst galaxies and look in wide imaging, you know, this is something that amateurs could actually do. Search for these potential dwarf companions, if you will. There's definitely more out there to be found.
Now, Al, if I could just say for 1 second, if you don't mind.
Sure.
To me, it seems plausible that it wouldn't necessarily have been a kind of a relatively recent collision. This could just be the effect of the tidal tail extensions as the object is on an elongated orbit around the larger galaxy, and the stars are just being tidally stripped away by the larger galaxy, and you get some of them that just follow orbits that gradually go ahead a little faster or trail behind. And if this thing is shown spectroscopically to have, you know, almost no younger luminous stars, that's more evidence that it's an older object that's been kind of like this for a while and not just very recently lost all its gas. So you have to look at the stellar content, and that'll give an idea about how long ago the gas was stripped away. And it could be, you know, long enough ago that maybe this could be after a couple of orbits around the galaxy or thereabouts. So it could be hard just to draw a conclusion about a very recent event just from that alone.
Yeah. Okay, thanks.
Well, another thing too, if it was actually a direct collision, I think that the way the older stars there in that little dwarf galaxy, it probably wouldn't have as much of a linear extent like that. There would be more. I think it would be much more disrupted, almost isotropically, if you will, rather than this long cigar shape. If it was more of a near direct hit.
Yeah, I'm not sure if they've done a simulation as to what it would be and how many orbits it would take to take on a shape like that from a spheroidal initial shape. But you know, something it's somewhat comparable in mass to the primary, and it can really disrupt you know, any spiral bars that the primary might have had as well. If you've got something this large, you have to eat, and it turns out screws up your main axis of rotation quite a bit. So that's another possible reason why this is an irregular rather than a spiral. It's quite it's not a small galaxy. It's about 25,000 light years in extent, which is maybe a third of the size of the Milky Way in terms of linear extent. So it's not tiny by any stretch. Okay. Any other questions? All right, thanks. Oh, can I just make an announcement about volunteers? Sorry. Can I just make an announcement about volunteers?
Absolutely.
Okay, before I go, I just want to mention something for the club. We are looking for outreach volunteers. We've got we've been invited to help out at Yuri's Night again this year with the Canadian Space Society out at the Air Museum there on the 17th of April. So if anyone's interested in coming out to help out and put on a display, please let me know. We're also looking for people who are interested in being on council as a national representative, and we're also looking for potentially people who would be interested in editing our newsletter, the Astronotes. So contact me if you're interested in helping out for any of those. Thanks.
Thanks, Al. All right, with some public outreach announcements, Mike, you're up. Thank you.
Next slide, please. Well, hi, everyone. Last Saturday, next slide, please. Last Saturday, we had Earth Hour. This was our second time that we've been invited by the museum, and you may recall last year it was a unexpectedly large event. Well, this year it lived up to sort of the expectations that was, I guess, set with last year. I figure we had about at least 800 people that showed up. This year we were prepared. We had a bunch of telescopes, and it really worked out well. There was we had our typical show, more emphasis on light pollution. Rob Dick was there. We had a nice indoor display. The museum set up their Star Lab planetarium, and we had a fleet of telescopes outside. So it was a good show. Let's go on to the next slide. Setting up here, you can see all the telescopes sort of oriented to the moon there, and then after Venus showed up in the sky, they all went over to Venus, and then Jupiter, and what else was probably Mars, and back to the moon, and then later in the evening Saturn. But quite a night for the planets, that's for sure. Next slide, please. The moon was really great. Nice quarter moon, and it was a nice quarter of Venus as well. And that was really nice because when we were showing people Venus, they were saying, "Hey, how come it looks like this?" And then I said, "Well, it's for the same reason why the moon looks like that." And we explained the orientation and so forth, and it was just a terrific demonstration. Next slide. By the way, all these photos are from Eric Kajula and Chris Tarrant, so really great. So some pre-observing stretching now. We're all looking at Venus, and as it was coming out, I think Chris Tarrant was the first to spot it, the bugger, and soon after we all saw it. What you can see there when Eric set up, I had such a nice long lineup on my telescope. It was kind of very gratifying, right? And then Eric set up, and just this giant over to Eric's. And then I looked behind me. I said, "Where'd everybody go?" So Eric had quite a setup.
I thought it was a small earthquake.
Yeah, that's right. Eric set up and he had his camera and hooked up to a monitor, and it was really nice. A number of people were sort of looking around, looking rather than everyone waiting to peer into an eyepiece. So it was really nicely done. Thanks, Eric. Next slide. That lineup you see in the back there is the lineup to the planetarium. Like last year, there was a really good not the planetarium, the observatory. Like last year, we had just a terrific number of people that lined up for the observatory, and then we had our telescopes off to the side. Thank goodness we were prepared this year. Last year we didn't expect the public turnout. So they had really good promotion. The Ottawa Hydro. And you can see this year we did something a bit different there. We had the stanchions set up, and that really helped, to make sure people don't trip over a leg of a tripod. Next slide. This was right at the end of the evening. I'm thinking, Tim, it was about 11:30 when
11:30, yeah.
When it was all said and done. So Earth Hour lasted a little bit more than 8:30 to 9:30, but and I think by the time I got in my house, it was like 12:45, and it was the post observing chat. So that was all good. But I really was encouraged by how prepared. We really were quite well prepared this year, and one of the best shots I think I've seen in my years at Outreach. You're going to see in this next slide here. So this is Julia Webster, Gordon's daughter. She stole the show. Okay, just to see her like bent down, looking up, and it's a precocious girl. That's no question there. But what a sweetie, that's for sure. Next slide. All right, terrific team. Lots of a couple of new faces you'll notice, and that's wonderful. All right, the outreach program has been really we've been really blessed with some wonderful participation. I wanted to say one thing because this is my last slide. I wanted to say one thing here. Peter Heyman. Peter, are you here tonight? I didn't see you. So Peter's volunteered to take on the Transit of Venus, coordinate the Transit of Venus event. That's really wonderful. If anyone wants to help him, I'm sure he would really appreciate the support. But that's obviously going to be a big event. Just from all the traffic I've seen on the various email groups, it's really something here. So I think that's it. Thanks, everyone.
Thanks, Mike. All right, and we have Eric up. Take it away, Eric.
Hi, everyone. I was at that outreach on Saturday, and the only thing that disappointed me was that during the Earth Hour, they didn't turn off the lights here. So, little glitch there.
Where to find them.
Yeah.
That's because the lights were out.
That's right.
And I did mention to people that when we observe, we like to go to dark sky sites, much better conditions. Also, I wanted to mention this is my 50th consecutive meeting that I have filmed. I have not missed a meeting in 50 months. And I have piles of hard drives full of video by now, terabytes worth, and I hope someday to put them all online, because you've all done awesome presentations over the last 4 years, and I'm glad to film them, and I just enjoy watching them again, and they're all available in the library, and just wonderful presentations, which I'll segue into my outreach that I did at Trivium School in Gatineau, which is across the river from Rockcliffe Airport. I did an outreach there in February. It's a private school that has about 200 students. They teach in English, French, and Spanish. And the quality of the education there is excellent. But I did notice something that Sylvie Letourneau mentioned during her outreach, that the teachers are under-equipped to teach the students anything about astronomy. And so I've lent our services to the school to, if they wish to learn more about astronomy, that we would do well to actually help the teachers as much as the students and so on, because astronomy for me is, it's actually a door that opens to all of science. Not just looking at the heavens, but it's actually the only public forum that addresses science in a very unique way. And I began my presentation to the school with an opening clip, an animation of Arthur Christmas, just to get their attention going. And then after that, I talked about the RASC and how easy it is to join, and that now we're actually doing a lot to try to involve young people in our society. The demographic needs to shift and make young students more interested. I was very inspired by Nicholas Zuger's presentation last month. I'm very encouraged by that, and I hope that more students do what he's doing. So I described the benefits of joining the RASC and where we hold our meetings every month, and also our website, which is very important because that's the easiest link we have to the public, is by telling them about our website. It's amazing how many people, including the outreach we did last Saturday, don't know about the RASC. Never heard of it. And so, you know, the website is the introduction to that. And after talking about the RASC and its history, I went on to, I asked them, what is astronomy? And right away I could tell that they don't know. So I gave a brief description of the definition of astronomy. And then I went into the history of astronomy, going back to Aristarchus, Hypatia, and then closer to Galileo and Stephen Hawking. So I showed them that astronomy is a lot about our history, and that there were a lot of people involved through the ages in doing astronomy and the impacts that it's had on our society. Hypatia has become my hero. I don't know if any of you have seen the film Agora, but that film sort of caught my attention, and I decided, well, I don't like to learn from films. I want to dig deeper and get into the meat of it, and learned a lot about her and her way of thinking, which was very revolutionary. Hypatia is considered the first woman astronomer, and she lived about 1,700 years ago, and her thinking revolutionized astronomy and probably even the women's movement, actually, because she had a lot of, she was a gutsy lady. And I explained one thing about that she said that inspired me was that thinking is important. Even thinking wrong is better than not thinking at all. And that's something that it's a very valuable life lesson. The other life lesson, I had the opportunity to let's go to an inside slide here. Let's show them what the class looks like in there. There we go. Okay, so I'm using a monitor. I prepared some slides, and the other life lesson I had the opportunity to teach them was to be able to say, "I don't know." When someone asks you a question and you don't know the answer, "I don't know" is actually a very intelligent answer. And so that's something I really wanted to get across to them. After that, we went into giving an overview of the universe. So I gave them a primer on the universe, and as I was giving him the primer, I was thinking, I need a primer on the universe. But one thing you're always scared of doing when you teach students about the universe is getting it wrong. And so there's a lot of bad astronomy out there. And so that's something I was very careful about. What I did is I worked my way out from the Earth to the solar system, the local stars, the galaxy, the Virgo cluster, and right out to what we believe is the current universe. One of the students asked me, how many cubic centimeters are there in the universe?
A lot.
And so I told him, I said, well, I'd have to do the math. You know, it depends on what shape we think the universe is. You know, if we assumed it was a sphere, it would be a very simple equation, 4/3 pi r cubed. But we have to qualify the shape to know how much volume it has. You know, the important thing is to try to give the best answer you have available. And I actually told him that I would get back to him later with a bit better indication of what it might be in size. The truth is we don't know how big the universe is. We have some estimates. Some people say it's 8 by 10 to the 26 meters in diameter. But that's just a guesstimate. I spent time teaching them about the concepts of orbits and gravity, and also about the sun, about how the sun is a giant nuclear furnace where a fusion reaction happens. Hydrogen is converted into helium, and the difference in mass in the conversion creates energy. And then after that, we talked about things like rockets, which we also highlight here at the RASC. And I held a bottle of water in my hand and told them, this is rocket fuel. And a lot of eyebrows raising there and that. And they did not know that when you break water down, you get rocket fuel. You get hydrogen and oxygen. And it's a very potent explosive, actually. And after that, let's go to another slide, just a little different angle. Let's see, we see the RASC logo in there. Another slide. Okay. I concluded my talk with my interest, which is impact craters. I'm actually here because of Mr. Chuck O'Dale, who introduced me to the RASC 7 years ago now, Chuck. Yep. And I'm so thankful that I've been able to become part of this, and the impact craters are still my first topic. So we talked about our explorations of impact craters in here in Canada, and we've seen so many. We've been so lucky to be able to go to these places, and I was sharing that knowledge with them about impact craters. A lot of them didn't even know we had impact craters. They say, well, where are they? What do they look like? You know, and I showed them some pictures, and I brought some impact melt and shatter cones to explain to them what they are. I also gave them some materials that Mike provided, a little constellation guide and some literature in that, and that helps them because they bring it home. I get the question sometimes from students, did God create the universe? And I explain to them that, well, from the point of view of the RASC, we study the universe using science. And that I'm not here to really talk about God. I'm here to talk about how we use the science to do that. And it's a very useful question because then it explains to them what we do. That science is the basis of our exploration of the universe. And that helped them a lot. I'd like to see more materials available to actually identify the RASC so that when they do bring it home, they know more about us. That would help a lot. And I have something here that I wanted to read to you that was inspired by a hero of mine. We celebrated him recently. And it says, the most important thing we can do is inspire young minds to advance in science, math, and education. If we do so, youngsters will be the economic engines that propel us to a brighter future. John Glenn. So I think we have a lot of work to do. We operate with no funding, no financial assistance. If anyone's been watching what they're doing in the States, NASA's providing a lot of funding right now to outreaches similar to what we do. And I would hope that the Canadian Space Agency or someone would help us a little bit along the way. And we need more volunteers. If you have the time to go to a school and teach what you know about astronomy, you should do so. It's important because it really lays the foundation for a lot of young minds in their pursuit of science. I couldn't think of anything better than astronomy to do that. Let me just check here. I plan to do as many outreaches as I can, and I'm open to all invitations in English or in French. And I'm proud to represent the RASC in those outreaches. Thank you.
Thank you, Eric. Nice to see when young minds fire up on that, eh? Yeah, good feeling. All right, perfect dovetail. Actually, we're going to we juggled our program a little bit because we are running a little bit behind. So we're going to jump into Chuck's presentation on some cratering.
That's a surprise.
Yeah, I know. Keep you on your toes.
Let's see, where am I now?
That's you.
Okay.
Surprise.
Do I have the go fast, go slow thing? Where are we here? Okay, let's see if we can figure this out.
See if I can figure this out.
Okay.
Oh, here you are, Chuck.
There we are. Oh, there, I was wondering where my airplane went. That's thanks to Brian. That was great. Okay, do you have the forward back thing?
Actually,
We don't, eh? Okay, I'll
babble
just,
at me.
I'll tell you when to go then.
Yeah, you like telling me what to do anyways.
Okay, next slide then. Okay, I started off this presentation by going through, I was going to show you some of the craters that I've explored that are actually underwater. And in my research, I found that I've exposed a monster. There's so many things to learn about craters that I had to stop my research and just stop. And actually, about 4 o'clock this afternoon is when I did my last notes here. So next slide, please. Okay, so I'm going to start off by one underwater crater I bet you've never heard of, Montaigne. Did I pronounce it right? Next slide. There it is. It's right off the coast of Nova Scotia. I wanted to show it because I have it on my website anyway. It happened 50 million years ago. Most of the modern mammals were just starting to appear. Many bird orders appeared, and reptile fossils were very abundant at this time, 50 million years ago. And next one. Next one. Right there. That's about when it happened. And the next one. Okay, this is how far it is off the Nova Scotia coast, and that's about the scale of it right there. This is a gravity anomaly map, and this is how they discovered it in the first place. It's 11 kilometers wide, and it's in 115 meters of water, so obviously I couldn't see it from my airplane. It is filled with shock deformation features, and that's how they actually identified it with a drill. Next one. And they did drill, and I want you to note that there's actually 3 stages here. One, the sediments. I'm going to refer to that in a bit. The melt zone, this is where they actually could date the crater, identify the impact melts and so on, and finally right down to the bedrock. So yes, it is a definite crater, and it did, we don't know how much of the evolution of the continent it had an effect on. And this is what I was starting to investigate. Next slide. But I got as close to it as I could from my airplane. This is Shag Bay, just in the south coast of Nova Scotia. And where the arrows are, right through the fog there, that's about where the crater is, about 200 kilometers off the coast. And there was no way I was going to fly out there to take a picture, so I stayed where I was. But as I mentioned, I was looking for some kind of effect that this crater might have had in Nova Scotia. And I got involved with the ejecta, and it's basically, I wanted to find out what effects the craters had and what signals they've left for us to find. And essentially what I've seen is distal ejecta layers. Now, we all know about the KT layer. Next slide, please. When the old dinosaurs made their Waterloo, and there's our little ancestor running for his life. This was 65 million years ago, and one of the major distal ejecta layers called the KT layer. This was found in the 1980s before we even knew why the dinosaurs disappeared. Next one. And next one, right there, 65 million years ago. So it was about 10 million years ago before the Montana crater, and 10 million years is about the time where humanoids evolved from the first little mammals you saw there to what we're doing now. And next one. So I'm talking about distal ejecta layers. This is the KT boundary, the Cretaceous Tertiary boundary that was discovered worldwide because of the Chicxulub impact crater. Now these layers, there's actually many of them I found. There's the KT, of course. Sudbury has a ejecta layer around. Manicouagan, there's an ejecta layer over in Scotland. Some of the craters in Europe actually have ejecta layers. And it was from this distal ejecta layer, like this, where they, actually Dr. Hildebrand, part of the RASC, was a very major contributor to this, was actually used these layers to research exactly where the crater is. Next one, please. And it's right on the Yucatan Peninsula. You can just barely see it. I don't have the laser. We don't have a laser, do we? Oh, we do, by golly. Anyway, you can see the kind of the circle in the... I have one here. Yeah? Do you have one? Hey, Brian, to the right. I got it. It's silver. Silver button? Thanks very much. Yeah, you can see the shape of it here. And it was funny that they knew that shape a long time ago before they even realized it was a crater. These are the cenotes. They're the little holes in the ground from the sedimentary rocks that rain had sort of eroded through and left a bunch of holes. And they tended to be in a circle like this. And it was one of these things that's sitting there right in front of you, but we didn't really know it was a crater. Well, Dr. Hildebrand, from this distal ejecta layer, calculated where the crater should be, and lo and behold, yes, there was a crater here. And even before Dr. Hildebrand found it, oil companies had actually drilled off here looking for oil, of course, and they actually drilled through a breccia layer similar to the Montana one I just showed you there. And from that, they extrapolated to say, yes, this is probably the killer asteroid crater from the dinosaurs. And from there, of course, it's history. There's been hundreds of thousands of papers written on it now, which shows that, yes, this is probably, most definitely, 99% chance of the demise of the dinosaurs. Next one, please. So, what we're looking at here is a distal ejecta layer that happened 12,500 years ago. And it's right where we're standing right now. It, just give me a second here. We found this layer is similar to the KT layer. It has the similar properties, iridium, glass spherules, and a new thing that we've just started to research, and we had a talk about this just a little while ago, nanodiamonds. Al Scott gave a presentation on this. And nanodiamonds are kind of unique. I'll get into it in a second. Next slide, please. So this 12,500 years ago, this is called now the Younger Dryas. It was right at the point where this black mat, or the distal layer, has been discovered. And it preceded what is called the Younger Dryas. And right at this point, lots of things disappeared. This woolly mammoth, for one thing. The Clovis people, the Clovis were a race of people who had the most advanced technology on the planet at the time. And they disappeared. So before this time, mammoths existed. After this time, nothing happened. Why the temperature went down, I'll explain in just a little while. It's kind of neat. Next one, please. So what happened is a lot of large animals just disappeared. All this was there, and then poof, within an instant of geological time, disappeared. Why is the problem? So, next slide, please. What we have is a distal ejecta layer across North America. Now, this is another one, totally independent, probably a talk of another, a subject of another talk. It's a distal ejecta layer in the Australasian field. And again, there's absolutely no crater to identify for that field, and it's full of tektites. Ron has a few. I have a tektite from that area. It's definitely an impact, but there's no crater. Same here. We've got the distal ejecta layers found in Europe and all the way through North America. And what I'm going to do is show you exactly what's in there. Next one, please. Oh, that was Greenland as well. There's one in Greenland. So there's a collection of the distal ejecta layers that we found across North America. And all at the same time, something happened. You can actually see it there. Something actually happened. What, we really don't know yet, but I'm going to show you some evidence that we think we know. But what we know for fact is that the woolly mammoths lived there. They didn't live here. The Clovis population, the highest technology that we had, lived here 12,995 years ago. Now 12,900 years ago, they didn't. That's a fact. Within these layers, I'm going to read them here. There's magnetic grains with iridium, magnetic microspherules, charcoal, soot, carbon spherules, and glass-like carbon-containing nanodiamonds. Now, all of those are indications of an impact, and I'm just going to concentrate on the nanodiamonds tonight. But just to point out, there was a sudden disappearance of the first Stone Age people in North America right at that point. 35 mammals, 19 bird genera became extinct. And the sudden cooling of the planet lasting 1,300 years happened right at that point. So something big happened. What is the question? Next one, please. Okay, this is an example of this distal ejecta layer. It's called the black mat. This is the one in Arizona. I mentioned the Clovis people with their technology. This kind of Stone Age technology was only here on this planet. Apparently there was a couple places in Europe, they think, but North America at this period of time had the highest technology. Now just trying to extrapolate here, if that population wasn't extinct at that point, we might be at the stars right now. But they went poof. Anyway, so that mat, as I said, the mammoths were there, they're not there. And there was no indication of any humanoid environments until later up in that layer, maybe 11,000, 10,000 years ago. Next one, please. So, what the geography looked like, we had the Ice Age. There's a big ice cap here. This black mat was down here, the picture we just showed you. All these points here had all those materials I explained to you, plus the nanodiamonds. And I just want to point out, right in here was a large lake. It's not shown in this diagram. It was called Lake Agassiz, and it was melt, like the glacial parts were here, and there's a giant lake here, probably the volume of the Great Lakes plus. And that's going to be significant in just a little while. I just wanted to point that out. And next one, please. So here we are at this black mat. This is in Arizona. There's no in situ Clovis points and extinct the megafaunal, those woolly mammoths. There has nothing been found at the mat or above it. But below the mat, there's lots of those fossils, plenty of them. This indicates that the mammals and Clovis hunting technology disappeared simultaneously. Basically, those extinct animals plus the Clovis population disappeared. Next one. And looking inside the mat, we've got, these are glass-light carbon lumps, carbon spherules here, and magnetic grains rich in iridium, these ones here. And iridium from the KT boundary was a definite indicator of an impact. Iridium is an element that is common in meteorites, comets, but is not common on the Earth because it's a very heavy element. And when the Earth was molten, of course, the heavy element sank to the core. Whereas if you find iridium at a layer, the KT proved the fact, yes, it is an impact that caused this iridium spike at that point. Next one, please. So, and again, an example of the Clovis point. These magnetic spherules, they are significant, and you'll see an excellent picture of why in a few minutes. So no human artifacts, including a lack of occupation for many years after that mat. So there's no occupation at all up here from humans. Next one. Now this is in Manitoba, and we have an iridium spike here. And this indicates that it might be close to the impact site. Iridium is extremely sparse on the Earth, but is abundant in meteorites and comets. I mentioned the lake right beside the glacier just a little while ago. It's called Lake Agassiz. I think I pronounced it right. The hypothesis is that if there was an impact on the ice sheet, that broke loose that lake, caused it to flow into Hudson Bay, through the Hudson Strait into the Atlantic Ocean, of course cooling the ocean substantially, causing this Younger Dryas cooling period for the next 1,000 years. That's a hypothesis, but it's a possibility, I suppose, with that impact. Next one, please. Okay, so I got into nanodiamonds. In 2008, we're getting pretty close to today, a discovery of nanodiamond-rich layer in the Greenland ice sheet. This is the first highly enriched discrete layer of nanodiamonds observed in a glacial ice anywhere. The diamonds were found embedded in metal alloy cosmic grains, and they were not free in the ice, so they're embedded within the grains here. Next one. So this is the spike of nanodiamonds. Now, nanodiamonds are common in meteorites. So what you have the noise from, there's meteorites landing on the planet all the time. So you're going to get the noise level of nanodiamonds found along any line. But all of a sudden you get a spike. So something big must have happened. And the chances are it's from an impact from a bolide of some type. So it is probably close to the impact site. And another point is that at this point, as an aside, the Niagara Falls Gorge started at this time as well. It's not a connection to my talk, but I just wanted to mention it as a trivial piece of information. It'll be on the exam. Next slide. So now we're coming up to a very close piece of research. This is a paper dated March the 5th, 2012, just last month. This is a lake in Mexico. Nanodiamonds called lonsdaleite. They're also called hexagonal diamonds, and there's one professor actually called them detonation diamonds. They were conclusively identified in this lake, Lake Cuzio in central Mexico. A 27-meter-long core sample drilled from this lake contained a 10-centimeter thick carbon-rich layer containing the nanodiamonds. The nanodiamonds were 20 to 1,800 nanometers in diameter. That's pretty small. This carbon-rich layer is consistent with the younger Dryas boundary layer found at numerous sites across North America, Greenland, and Western Europe. The researchers also found spherules that had collided at high velocities with other spherules during the chaos of the impact. Again, this is another definite indicator of a cosmic velocity collision. Next one, please. So we're getting into some technicalities here. In another life, a long time ago, I was in semiconductor failure analysis, and I used scanning electron microscopes just about every day. And this is technology used from a scanning electron microscope. First of all, it's a transmission electron microscope, which what it does, it sends a very high energy electron beam through a very thin sample. And what we get are called selected area diffraction patterns. And these patterns will identify the crystal lattice of lattice of these diamonds. And doing this research, I've learned a whole bunch of stuff. And another big word I learned is called allotrope. I never heard of it until I did this research. But what it is, it's the ability of an element to exist in two or more different forms. Very important. Now we're getting into nanodiamonds here. These are definitely identified as nanodiamonds. These diffraction patterns define the crystal lattice of the diamond itself. So what does this have to do with impact? Okay, next slide, please. This is from the Mexican site, and this diamond here is definitely identified as a lonsdaleite. It is a hexagonal diamond, a detonation diamond, and it is a allotrope of nanodiamonds. It is definitely, absolutely, the result of a cosmic impact. The only thing that would have as much energy as this is probably a nuclear explosion or a cosmic velocity impact with our planet. So this is almost the smoking gun, the same smoking gun as the iridium in the KT layer. So, in nature, it forms when meteorites containing graphite strike the Earth. The great heat and stress of the impact transforms the graphite into diamond, but retains the graphite's hexagonal crystal lattice. In other words, from an impact, this is the crystal pattern you get, and it's only from the energy from an impact. This element, lonsdaleite, was first identified in 1967 from the Canyon Diablo meteorite. That's the meteorite crater in Arizona, where it occurs as microscopic crystals associated with diamond. They are also found at Chicxulub, Kara, Ukraine, Rays, and the Sudbury craters. So these are definitely associated with impacts. Next one, please. Now this is my personal sample of the Tagish Lake meteorite, the one that impacted here a while ago. It was originally was a 56 metric ton meteorite that rained down over a wide area of Canada in January 18th, 2000. And I mentioned earlier that nanodiamonds are 99% found in meteorites. They're not a natural part of our planet. They're found in meteorites. Next one. So, doing a little bit of research in my home lab. It's the carbonaceous. The Tagish Lake is a carbonaceous chondrite. It's a type of meteorite. It has a nanodiamond abundance of about 4,000 parts per million, and this just happens to be the most populated meteorite with nanodiamonds found so far. They're contained within the carbon within the meteorite. Now, I'm looking at, see this guy here, that's about 2 microns across. So a nanodiamond I quoted was up to 18 nanometers, which is over a micron, 1.8 microns, down to less than your visible site. So these are either nanodiamonds or carbon containing a nanodiamond. It was fascinating exploring this meteorite. I just love it. That's okay. I was going to that one anyway. And as I mentioned earlier, the spherules were found in the Younger Dryas layer at Lake Cuzo in Mexico. These spherules collide and fused, which happens only during a cosmic velocity impact. So the evidence is there. And remember, it was the investigation of the KT layer that allowed us to find where the KT impact crater was. This was actually Dr. Hildebrand was prime on that. So, the highest, next one please. The highest concentrations of the extraterrestrial materials that we found occur in the Great Lakes area, up in here somewhere. And basically it gets less and less from there. Some are found in Europe and some in Greenland, but the concentration seems to be around here. Next one, please. So I've documented empirical evidence for an impact somewhere in or over North America that coincided with extraordinary biotic and environmental changes here in the last 20,000 years. Basically, something big happened 12,900 years ago. The implication is, yes, it's an impact. Where is the crater? Well, I'm getting into my personal opinions now. This is my hypothesis. English is not my forte. The plural of hypothesis.
Hypotheses.
Hypotheses?
Yep.
It's not hypothesi. Okay. Okay, next one, please. Hypothesis number 1. Now, we all remember Comet Shoemaker hitting Jupiter. So we know that comets do disintegrate. Comet just recently disintegrated close to us as well. I can't remember the name of it. Next one, please. So, 12,500 years ago, my thoughts, that one that hit Jupiter was a factor of 19 times the energy that hit Tunguska. I figure this might have happened 12,500 years ago. Fragments and debris from a large comet hit our atmosphere, producing a large aerial burst, or bursts. So Tunguska, next one, was about 5 to 30 megatons. The event is consistent with a stony impactor 30 to 40 meters in diameter, exploding was about 6 to 10 kilometers above the planet in the atmosphere. So could the Younger Dryas event be a multiple explosion? The cause be a multiple explosion of this type? Well, that's one of my thoughts. Okay, next one. Hypothesis number 2. Could it have happened on the ice sheet? Again, this is Lake Agassiz here. Apparently, it did drain into the Hudson Bay and out, which caused the Atlantic Ocean to cool substantially, which caused the 1,000-year cooling period. So getting back to it here, my hypothesis again, an 8-kilometer wide bolide had broken up in the atmosphere and that most of it had hit the Laurentian ice sheet. Okay, so what, I say. Okay, next one, please. If you've been a a fan of the Discovery Channel and Naked Science. Dr. Schultz here has been a star for a while with his big cannon. He impacts stuff and shows what gets close to a cosmic impact speed. 12 kilometers a second is the escape velocity of our planet. So a bolide with the minimum velocity would be 12 kilometers. I think the gun that he uses gets close 12, 13 kilometers a second. That's about it. But even so, he's done a lot of research. And what you're looking at here is an impact flash at the NASA Ames hypervelocity vertical gun range. He simulated a low-angle hypervelocity impact into ice. And his results, as he calculates that a 1 kilometer wide bolide coming in at an oblique angle can hit a 1 kilometer thick ice sheet and leave no crater. And he would need, of course, there'd be a crater on the ice, but what he meant is that there'd be no crater on the surface under the ice. The impact would leave a randomized pattern on the surface after melting. 90% of the impactor's mass may be vaporized upon impact. Next one, please. Hexagonal diamonds formed in the temperature-pressure combination of this impact. That's my hypothesis for that one. So hypothesis number 3 is a multiple impact. And I want you to go ahead 5 times. 1, 2, 3, 4, 5. This is my final personal hypothesis. Okay, next one, please. First one might be, next one, Charity Shoal. It's just south of here in Lake Ontario. Next one. I've superimposed a circle. This is my aeronautical chart. It's right about there. Kingston's here. Charity Shoal is about there. It's 1 kilometer wide. And what's interesting is right in here is an indicator for pilots that there is an extreme magnetic anomaly. Basically, the compass goes wonky if you fly in this area. So don't rely on your magnetic compass, which implies maybe a iron object landing there. Could it be a cosmic velocity iron object? I don't know.
Have the people navigating on with a boat reported the same thing?
Oh yeah, yeah. You would find your deviation would vary by 5-10 degrees maybe. Next one. This is an example of Charity Shoal underwater, 1 kilometer across. That's the width here. We cannot identify that as an impact for sure. We haven't dated it, but it is one of the possibilities for an impact causing the Younger Dryas. Next one. This is a picture I took from my airplane over the shoal on a calm day, and that's the best I could. It's under about 40 feet of water. So that's crystal clear Lake Ontario, not bad. Next one, please. So the next one, is one in Nova Scotia called Bloody Creek. It is a crater 1/2 kilometer in diameter. It's 10 meters deep, and it's just been found, and planar deformation features have been found in the area. Planar deformation features is shocked quartz, which again is a definite impact, definite indicator of an impact. Next slide, please. Okay, this is a movie. Let it roll. See if it works.
Hidden underwater in Nova Scotia's Annapolis Valley could be the answer to one of the great riddles of Earth history. What wiped out North American wildlife? Saber-toothed tigers, mastodons, woolly mammoths were gone in an instant. Now, as Daryl McIntyre discovered, a Canadian scientist is on the hunt to find out what happened so long ago.
It may not look like much from the air, but to scientists who know better, Nova Scotia's Bloody Creek Hydro Reservoir holds a discovery that's got researchers around the world buzzing.
It's mostly underwater right now, though some of those small islands sticking up form the rim of the crater.
Hidden just below the surface is a crater nearly 1/2 kilometer long. Aerial photos taken before the land was flooded show it clearly. A rare oval-shaped crater formed by a low-entry meteor.
The meteor, when it came in and struck, had to be coming over the horizon at 15 degrees or less. So streaking across the trees, it would have been, something incredible to see.
Dr. Ian Spooner has studied the crater for 2 years.
It would have been the last thing probably anything in at least a 500, maybe even 1,000 kilometer radius would have seen. The destruction would have been total.
Early clues suggest this may have just happened, in geological terms, about 12,000 years ago. And that's got the attention of scientists of all kinds, including one who thinks this site may finally answer an archaeological riddle. What caused the mass extinction of saber-toothed tigers, mastodons, humans, almost all large animals in North America at the end of the last ice age?
These animals were major players in the landscape of North America up until exactly, we suggest, 12.9 thousand years ago, and then they were gone. Gone in an instant.
Dr. James Kennett thinks a meteor strike is to blame, and Bloody Creek could prove it.
This may be representing a smoking gun, if you like.
Ultimately, the answers lie in core samples taken from lakes around the crater. Using layers of sediment to count back through the centuries to that global cold period, Ian Spooner is now searching for signs of a cosmic element that would have blanketed the area at impact.
So if we saw an iridium spike in this core, then, especially if it was right here, right at that point, and that's right before this younger driest cool interval, then there'd be something that would be a very provocative result. We look out into the distance here.
In fact, Spooner says it would force scientists everywhere to rethink their understanding of one of the biggest global catastrophes ever. Darryl McIntyre, CBC News, near Dalhousie, Nova Scotia.
Anyway, essentially what happens, these are scientists that have investigated the crater. It's under a swamp right now, but as I mentioned, they did find planar deformation features. It is associated with the Younger Dryas extinction. The dating of this crater is very close to the Younger Dryas initiation. And you can see the size of the crater here. And this is scientists talking scientific stuff. Yes, it is a crater. Yep, it definitely is a crater. Yep. Chuck O'Dale will look at it. Yep, there we go. But anyway, it's if anybody wants it, I have it on my computer. I can email it to you. It's a short little clip from the CBC. And actually, the Nova Scotia RASC was involved in it for a while, a few years ago. Unfortunately, now they put a dam on that little creek. And this is a doctor, I can't remember his name now, but he was the first one to identify the nanodiamonds in the Greenland ice sheet that I showed you earlier. And these are the extinctions that they're talking about. Right at the 12,000, poof, all these guys were gone. It was, yeah, Kennett. Again, he was on the Science Channel, The Naked Science, and he was on the NOVA, actually. The NOVA one I quoted earlier, he was the guy that discovered the hexagonal diamonds within the carbon spherules within the Greenland ice sheet. Anyway, yeah, just jump ahead. Okay, that's a picture of it before they put the dam on, and it's fairly substantial. Half a kilometer, half the size of the Charity Shoal, but still substantial. It would have been one heck of a hit, and it would have the fireball probably would have gone as far as Quebec City. So it gives you an example of the energy that you're looking at here. Okay, next slide, please, and the next one. There's a brand new one that I just read a paper about, published just last year. Next one called Corosol Crater. It's just south of Sept-Îles, and it's right in there. Again, it isn't 99% identified as a crater. They haven't got any in situ rocks from the site, so they can't say that definitely it is a crater, but they did find impact breccia with a planar deformation feature within the site. Not in situ, but very, very suggestive. Next one, please. So that's a close-up of it. It's 4 kilometers in diameter. So 1 kilometer for Charity Shoal, a half one for the one in Nova Scotia, and 4 kilometers here. So they're pretty big. And again, the fireball would probably go across half the country on this one. It's rise about 70 meters, the central peak. And the valleys here is 160 meters deep. The carbon-14 ages of the shells in the sediments can be extrapolated to give an estimate age of 12,900. It won't be younger than that. It could be older. Now, this is taken to the youngest possible age. It's the largest known crater in North and South America within the last 35 million years. So this happened just recently. Pretty cool. And next one. So up north, Eric and I flew over a little site called Merriweather. Again, next one. This could have been part of this as well. This is the fourth one of my hypothesi. There are actually 4 sites here. This is the big one. This is about 100 meters across. 1, 2, 3, 4. If Eric and I ever get there, we're going to do some science, because this one and this one have been sounded. They know the profile of the lakes, but these two haven't. So if we ever get there, we'll do some science, Eric. And finally, next one, please. There is a series of lakes up in northern Quebec. It could have been a swarm of craters. I don't know. You're looking at, over a kilometer across, and each one is about a kilometer. So again, if you're looking at impacts here, these fireballs would have been substantial. So these are my hypotheses for the impacts that we know that happened. Next one, please. So we've got the 5 impact sites. Lake Agassiz, again, when the ice failed, we got that large disruption, this large drainage of the fresh cold water into the Atlantic Ocean, which caused the Younger Dryas and the extinction. Next one, please. So here we are. What you're looking at here is the Hale-Bopp crater. Remember I mentioned the Chicxulub crater that caused the dinosaurs to go was 10 kilometers across. Hale-Bopp here is 60 kilometers. Now, if the Younger Dryas event was due to an encounter with a swarm of debris 12,900 years ago, the material would still be visible in the inner solar system. So, as I mentioned, this is a monster I've created. There is a paper by a guy named Dr. Napier, and he hypothesized that the extinctions are from a Truid complex of craters, of comets. And he gives several hypotheses of periodic comets and debris that may be the culprit. Now, this is a subject of a possible future talk, but we have maybe where the craters are and maybe what the comets were. Like, of course, we all know the meteor storms that we go through are comet tails. And if the comet and the Earth happen to occupy the same space at the same time, we know what happens. So, as I mentioned, Hale-Bopp here was 60 kilometers across. And I like to quote Isaac Asimov here. How bright and beautiful a comet is as it flies past our planet. Next one. Provided it does fly past it. Thanks very much. Yeah, rock and roll. And Brian, this is yours.
We got dueling computers here.
So this summer, again, we're going to continue the tradition of holding public telescope observing nights. We'll go to the next slide. So again, as in past years, we're going to hold them at the Carp Library. These are, if you're just, star parties, so just for those that don't know, members bring their telescope and then, invite the public to come and look through the telescope. I guess the other thing is if if you have a telescope and you need some help with it, that's another opportunity. You just come a little early, and then people would be quite happy to help you set up the telescope and give you some pointers. They've been well attended in the past. We've had dozens of telescope and a couple hundred people, so they're great events. I guess the stress is they are free. They're open to the public. That really is the purpose of them, is to introduce the public to telescope observing. One per month is what we plan for. It's obviously based on the weather. So from June until October, including October, and again at the CARP library, we'll detail in that in the next one. So what I've done is I've selected 2 possible moonless weekends per month. So that gives me 4 possible dates, and then the first cloudless day will announce that the star party is on, and then we cancel the other one. So one, hopefully, a little better odds. Last year and the year before, we did 2 consecutive weekends as possible dates in just one day. So we're trying to double the odds here. And then we'll update the website, the Ottawa RASC website. There's a link on the home page, or also a button on the outreach page. And then I update the schedule, hopefully before noon, but sometimes have to wait till the weather updates at noon. And we'll publish, when we can. Right. Next slide. The first one, or the first possible date in June, is the 8th of June. Nominal starting time is 9 o'clock. It doesn't get dark until a little bit later, but there's usually some stuff to see. And certainly if you're setting up a telescope, you want to come early enough to set up before it gets dark. And then the other dates there, you don't have to write those down. They're all on the website. And to say that's a Friday, the June 8th, and you have to check the website on the day of that event to see if we're actually if the weather's going to be appropriate. Next slide. So the location then is in the West End, Ottawa. It's CARP, pretty easy to find. They're again on the website. If you're not sure where CARP is, there's these maps and instructions on how to get there. But basically, it's just straight up CARP Road off the 417 and through the village of CARP, almost past, actually, pretty well past the village of CARP at the north end. The more prominent sign is the Diefenbunker and little tiny Ottawa Library sign, and most people have managed to find it in the past. Next slide. Yeah, so let's say the directions and the go, no-go decisions posted on the RASC website. And there's also a link on there with my email. It's under the CARP Public Star Party Coordinator. So if you click on that, then you get to send me an email, and quite happy to answer any of your questions then. Thanks.
Thanks, Stephen. For those of you that don't have access to a dark sky site, if your backyard backs onto the Queensway or something like that, that's a nice site actually. So it's not too far out of town, and you get some pretty decent skies there. Okay, next we have Brian talking about the Titanic.
Thank you. Before we get started, did anybody find a copy of this on the floor? It slipped out of my binder. Maybe it's at home, but that's okay. So to say in advance, thank you to Paul and Chris and also Tim for doing all the setup on the program here. This year is the 100th anniversary. This month is the 100th anniversary of the sinking of Titanic. The ship sank in April on April 15th, 1912. There's an article in this month's issue of Sky and Tell, the big burning question there: did the moon sink Titanic? I generally don't like astronomical things related to events like that. You know, did this event make the sky rain comets? And I don't normally like them, but I have a really strong connection to, I would say, to the ship as a former seafarer, and same as Chuck. And a lot of the things that were in Chuck's presentation, it's kind of interesting, in a sense, some similarities here. The article was written by Roger Sinnott, who's a contributing editor at Sky and Tell, and also 2 physics instructors from the Texas State University, Don Olson and Russell Dosher. So the question is, did the moon sink Titanic? Now what these guys did was they modified 2 different people's theories on what the connection was on the a conjunction of the moon being at perigee, its closest point to the Earth, the moon being full, and also the Earth itself being at perihelion, its closest point in its orbit to the Sun. So all these things converged on January 4th, 1912, and are wondering if 3 months later, or 4 months later, did that have the effect of loosening an iceberg that Titanic crashed into? All right, so let's go to the next one here. So here we have the pride of the White Star Line, the Royal Mail ship Titanic. So a number of things we know about the ship there. I mean, you can see it was the greatest ship of its time. Had all the mod cons, even in the third class accommodations, were much better than some of the first class accommodations in other liners of the day. They had things like electric heat, hot water in every cabin in the first and second class cabins. One of the interesting things, the ship here, was built by Harland and Wolff in Belfast, and she started construction in 1910. Right, so 2 years before she was she sailed on her maiden voyage. Now she was 883 feet long, 92 feet wide, and she was just over 46,000 tons, so a good-sized vessel. She had 4 smokestacks here, 4 funnels coming up from the boiler rooms and that. The aftermost funnel was a fake that was put on to balance the shape of the ship. It was mainly for aesthetics, but they also used it to vent the galley, all the steam and that coming up from the ship's galleys where they were doing the cooking. But all these other ones are engineering space exhausts, except for that one. What's interesting here that we really have to take note of now is that the ship had 16 watertight compartments. So going from forward to aft, you could box the ship off into 16 watertight compartments. So if you took water in a couple of compartments, you should be able to seal that off from the rest of the ship. Problem in Titanic was they built these great watertight bulkheads, doors that could close if there was any water coming in. Except the bulkheads didn't go right up to the deckhead. So if the ship was tilting, the water would just start flooding like an ice cube tray, just filling the next tray, filling the next one, filling the next one, which is exactly what happened. The other thing that plays into the story is that Titanic was carrying, she was fitted for, I think it was 32 lifeboats. She ended up carrying only 20. 16 wooden lifeboats, 4 collapsible. So they had a wooden bottom and canvas sides, so they weighed about a ton each, but and they collapsed. So they had spaces on board for 1,178 people. Which was actually more than the Board of Trade required them to carry at that time. That's the way the regulations were. They didn't have to carry enough spaces. The whole idea was a ship like that, the idea of a ship like that just sinking before other ships can come to its assistance. Basically, the idea with the lifeboats is you throw the bods into the lifeboats and you start ferrying them across to the rescue ships that are coming. But as we know in the story of Titanic, a number of things conspired so that worked against them. So they had spaces for 1,178 people. They were carrying 2,224 souls on board. All right. When the ship sailed from her last port of call, anybody know what the last port of call for Titanic was before she started running or westing down across the Atlantic? Queenstown, Ireland, which is near Cork. It's a cove, C-O-B-H. So that's where she sailed from. And I'll show you on the map in a bit. So we'll go to the next one, please. So here's I don't even know where this image came from. But the point I want to show here is that if only it had been daylight when Titanic did that. We know what happened. Titanic was blasting across the North Atlantic at full speed and ran into an iceberg in the dark. If it had been daylight, probably would have avoided a collision. The other thing was it was a very calm, steady night, moonless. The moon wouldn't come up until much later. It was just days before approaching new moon. So it was a very clear night, but no moon in the sky. When you're at sea, when the moon's up, you can see for miles. Even if you can spot icebergs and that, I've done it. I can see icebergs. If there's some wave action, you can see the waves where you'd be seeing this type of action against a ship. You can see that. You can see the waves breaking on an iceberg. And that's where you can tell that you've got ice ahead. Also, there's something also known a little bit of ice blink. You can see there's atmospheric conditions that show the presence of ice. But these guys were cranking along at 22.5 knots. So on the 3 nights after they left Queenstown, Ireland, at 11:40 p.m., the lookout in the... We'll go to the next one, please. Yeah. The lookout in the crow's nest of the ship reported iceberg right ahead. The orders were passed down, and the ship turned her helm over and cranked around. Actually, we'll go back when I went ahead too soon there, Tim. Thank you. So what happened was that people thought that originally that the ship had torn a 300-foot gash in her starboard side. In fact, it was 6 specific spots where the plating had been punched in. Now, the plating on that ship was overlapped and riveted. So what happened when the iceberg collided with the, or Titanic collided with the iceberg, it actually punched things in a bit and left little openings. So in a sense, Titanic was sunk by a slow leak. But it was a long, big, slow leak that got that filled the ship up actually very quickly. So it didn't look like much, is what I'm trying to say. It didn't look like much, but it was deadly. So the thing is, the ship had been receiving wireless signals. She was carrying a Marconi operator who was an employee of the Marconi company. She had a Marconi operator on board who was sending a lot of traffic, personal traffic for the first-class passengers. He was communicating with Cape Race, Newfoundland, and from Cape Race, that's where they transmit the Morse code to all the other stations so that people sitting in San Francisco can get a little note from, oh, message in from, telegram from Titanic. And that's the way they did it. Cape Race, Newfoundland was the relay point. The ship Californian was only about 10 miles away. She had been sending ice reports out to all the ships that were listening. Some of the ice reports were received by Titanic, but there was one where Californian was trying to tell Titanic they're closing in. Californian had actually stopped in the night. It was too dangerous. They said they were in pack ice, there were large icebergs, they were stopping for the night. And the Californian Marconi operator tried to get hold of his buddy in Titanic and say, hey man, here's what's going on. And the line from Titanic back, this is on CW Morse code, from Titanic to Californian was, shut up, I'm working Cape Race. Get out of my hair, I've got first class passenger radio traffic to get through. So that last message never made it up to the bridge. So the people navigating the ship were not aware that basically 10 miles ahead, 10 nautical miles ahead, you could be running into pack ice. And they were still cranking along at, you got a 46,000-ton vessel moving at 22.5 knots.
Brian, do you believe if the ship had hit head on the ice?
Well, let's do that at the end, okay, if you don't mind, because I just got to sprint along a little bit here. All right. So the next thing that happens, we'll go to the next slide, please. Okay, CQD, CQD, SOS, SOS. Morse code. Da-da-da-da, da-da-da-da, da-da-da. CQD, that was the international distress call. SOS had just come out not too long before that. Titanic used both. Titanic was not the first to use SOS, but she used both signals. Unfortunately, at 11:30 in Californian, the wireless operator, I mean, he basically had got the shot up from Titanic and okay, and well, it's 11:30, I'm going to bed. In those days, they carried one wireless operator. He shut down his set at 11:30 at night. So California's not hearing any more messages. 10 minutes later, Titanic's run into the iceberg at full speed, and she's sending out this distress signal. So five of her 16 watertight compartments were open to the sea now. They're admitting water to the ship. The builder of the ship was on board, and he told the captain the ship will not survive 2 hours. And in fact, okay, so there they go. The best estimate of the number of people that were saved was, well, they know there were 705 who were saved. There were about 1,500 lost. There's some discrepancy on the numbers because some people were on the manifest under assumed names. There was a little bit of dodging around going around. They're not sure why that was. And when the ship went down, about 1,000 people were still on board that ship when it headed for the bottom. All right, if we go to the next one, please. All right, so there she is, 3,700 meters down on the sea bottom. Lee McDonald took this photograph of a model in St. John's, Newfoundland not too long ago. And there she is on the bottom. If we go to the next one, but let's back up for a second just to see what was going on. Oh, no. We'll go to the next one, Tim. And in my story, I'm backing up. All right, so here's the ship. Left Southampton. Where's my, here we go. She was built in Belfast, builders brought her down. Okay, she did her maiden voyage from Southampton, really picking up passengers in Cherbourg. That was on the 10th of April, and then overnight sailed to Queenstown, arrived there just before noon. At 1:30 p.m., she sailed across the Atlantic, chunk, 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 and then she turned the corner, which is when you're going across a globe, you actually cut over the top of the globe, and then you angle toward New York. So she was actually just a few hours past turning the corner now for running a rumline course into New York City. So what the authors of the article are saying, well, you have these icebergs that come off these various glaciers here. They're carried northward at first by the West Greenland current, and they go around, they bump around, and they come around down the Labrador current, and they come down through here. This is called Iceberg Alley. I've worked in ships operating in ice, lots of ice, through here and along here as well. And so when the ice comes down into the shipping lanes, of course, that's where you have to obviously exercise due seaman's caution to make sure that you're operating within your capabilities there. All right. So the story starts at in 1995. Let me back up one. In 1983, author Richard Brown wrote a book called The Voyage of the Iceberg that did in Titanic. So he talked about, well, how the iceberg went around this route and probably bumped and went aground, and tides lifted it up and it moved it along and eventually ended up in Titanic's path. In 1995, an oceanographer, Fergus Wood, suggested, well, but there was a conjunction going on. There was this, as I mentioned at the outset, of the moon was at its closest point to the Earth. It was a full moon at the time. The Earth was as close to the sun as it could possibly be. That meant there was a hyper effect on the tides, on the spring tides at the time. So where the oceanographer figured, well, this probably came off in that January 1912 conjunction of astronomical events loosened a piece of ice off the glacier here and brought it around. Well, you can't go from here to here, January to April. It's just not going to work. So what the authors in Sky and Telescope have done, and I urge you to read the article, it's quite interesting. They say, well, maybe both answers are right here, that they figure that probably an iceberg calved from the glacier maybe in 1910, 1911, bumped around probably before 1 or 2 seasons, because large icebergs can last 1 or 2 seasons, and came down into the path. All right. If we go to the next one, please. All right. So we can see the iceberg. There's one that's stranded in Newfoundland. It's just sitting, and whether or not that gets refloated or not, it's hard to say. It depends how much is down below. And here's an image of what could be a typical type of iceberg. This is why when we were at sea and we'd go up toward large icebergs, we didn't get anywhere near them. Because if something happens down here, suddenly the center of gravity changes and they just go flip like that. So you don't want to be anywhere near one of those things. But this is the type of mass. We see the little bumpy, you'll see a picture of the crater. This are the, talking like Chuck now. We'll see a picture of the iceberg. Picture of the iceberg that probably was the one that Titanic struck. Actually looks kind of similar to this. But you get the idea that it's not just this little chunky bit up here. There's a lot of mass. That ship, that 46,000-ton ship, ran into a lot of mass. 90%. Yeah, let's go to the next one, please. All right. So here's a postcard that a seaman on the ship Bremen, they were about 1,000 nautical miles astern of Titanic, doing a westward run from Bremerhaven to New York City. And they came along this, and he saw this, took a picture of this iceberg that showed it had 2 little humpy bits up here and up here. He said it looked like Gibraltar. And if you see images of Gibraltar, it looks like Gibraltar. He noticed there was damage on here and discoloration on the iceberg. So they're figuring that probably was the one from the descriptions at the time of what the iceberg looked like. Okay. So he sent this postcard home. So now let's go to the next slide here, and I'll show you. Here's what the Sky and Telescope people are saying conspired to put that iceberg in Titanic's path. So as the Earth's going around the sun, at some point the Earth gets closest, in wintertime, of course, to the sun. That's perihelion. All the time, the moon is zipping around the Earth, producing the tidal bulges, and the tidal bulges go in line with the line of the Earth and the moon. So as we get around to here and around to here, the phase of the moon was now full. It was a full moon, and here it is closest at perigee, closest point to the Earth that it can possibly get. And in fact, it was a very close perigee of 356,375 kilometers is what they have calculated for it. And so now we've got all of this force magnifying the effect of the tides. So if those tides went and loosened the iceberg, we'll go to the next one, please. This is what you end up with. You end up with these nice chunky bits coming down through Iceberg Alley. That's me at sea in 1974. I was circumnavigating Newfoundland. This is just going around the northern tip of Newfoundland. We're heading towards St. Anthony. And that was I think that was the second iceberg I saw. I'd seen a little one floating in Forto Bay in Labrador. All right? But we were told, you don't mess around with the ice. And we learned early, if you're in an area where there is ice, reduce speed. If the visibility is low, reduce speed, and that's always the mariner's answer to things when you've got navigational dangers. Okay, so in a sense, Titanic should have reduced her speed and probably should have done as Californian did and hove to or lay to. If we go to the next one, and we're just coming to the end here. All right, so another chart, just like Chuck's. Just copycatting. So this is the areas that I was working. It's just a little point of interest here. St. Pierre and Miquelon, the French islands are right here. They also have a fishing zone that goes right through the Canadian exclusive fishing zone. But it's long and narrow. Goes down to here, and they call it the Baguette, Le Baguette, for obvious reasons. But here's the thing. When I was operating at sea, we were doing fishery patrols. We'd be down on the fishing banks here, on the banks here, in the Gulf, all around the fishing banks, Flemish Cap and everything over here. And down there's Sable Island. And we actually went over this spot. This is the spot where Titanic sank. That's the spot where Titanic sank. 160 minutes, from 11:40 p.m. until 1:20 p.m. The next morning. Is that 2 hours and 40 minutes? Okay, 160 minutes. So in the time it took you to come to leave home, come to the meeting tonight, sit here through the meeting, and the time to drive home, from the start of that to the end of that is when iceberg ahead to the ship is gone. So if we go to the next one, I mean, we talk about the astronomical connections. But for me, it's a very personal story. They're the people in collapsible lifeboat D, and as they were being rescued. But the story there, I mean, what we go to the next one there, I mean, there were people, obviously, who were never recovered. That's one of the Titanic's chairs that was brought back from the cable ship Mackie Bennett that went out and was recovering bodies, and that's in the Maritime Museum at the Atlantic in Halifax, and Bridget and I were just there at the beginning of the month. So 160 minutes, and there it was. So she went from being the greatest ship of her day to the world's greatest maritime disaster. So if you go to the next one, so it's a story of the dead. This is the cable ship Mackie Bennett crew found a kid of maybe about 2 years old. No, I don't think it was ever identified, and they paid to have this memorial put up for the little gaffer. And back here, this is one of the saddest stories of Alma Paulson. One kid, I can't read the numbers, age 8, age 6, age 4, age 2. She and 4 of her children died in that. So it's a story of the dead, but it's also one of the living. Because we carry the memory of what went on that night. If we go to the next one, please, Tim. We carry the memory of something that goes on, and because we're human, we commemorate with our stories, with our stamps, and also with our music. So what happened is that we pay tribute to this new coin that just came out. We pay tribute to Titanic in this century year of losing her, and to commemorate the great liner's never-ending road through history.
Thank you, Brian. That was awesome. We, in the sake of, for the sake of expediting things, we actually removed one of the slides Brian had as part of his presentation, which is a really superb animation done by National Geographic Society showing how the ship went down. After the end of the meeting, if you've got a few minutes, you want to stick around, it only runs for about 3 minutes. We're going to run that animation. It's really cool to watch, basically showing the ship running against the iceberg and how she broke up and finally went down. So, well worth seeing if you've got a few extra minutes. So first up on deck, Sylvie Letourneau. Sylvie Letourneau.
Okay, so the point here is not to show that I'm starting to do astrophotography at all, but no, it's just one of those digital moments. So I was, well, attracted by Venus and Jupiter in the sky. And before I go to the next slide, I just want to point out that this is a flowering tree, and this picture was taken in March. Next one, please. So that picture was taken just after 7 p.m. on March 15th, I believe. And then I turned around and I took the picture of Mars, which is right here in Leo. You have a nice little snapshot from Sky Safari to prove it. And then 5 minutes later, next one, I took a picture. Sorry, Saturn is right down here, right here. Just like you saw, okay? So in about the span of maybe, 10 minutes, I saw four planets, took their pictures, and from one end of the sky, I could see the Polaris, which was really low on the horizon, and on the other, on the southern sky, the Southern Cross was coming up. So, in other words, I was in Barbados, and those are my trip pictures. Thank you.
Next up is Rob Dick.
Yep, here we are. This is his light pollution slide.
So Sylvia's in Barbados. Jeanette was on a business trip, and my son and I essentially went with her. And so this is the big eye in London. Of course, being astronomy, you got to do something. And unfortunately, that was just about all you could see from London. But anyways, kind of neatly framed with the big eye. Go to the next slide. When we heard that we could take the channel, we thought we'd go to Calais and back, but the train doesn't stop in Calais. It goes all the way to Paris. So sad. So Jonathan decided he wanted to go to Paris. So here we are leaving Paris and searchlights, and look at those stars. Well, no, they were actually lens effects. I couldn't see anything except for Venus, Jupiter, and so on, the moon from that lit city. So anyway, just it was rather interesting, and it's amazing what you can get done with a digital camera. I couldn't do that at all. That's handheld, so that's rather remarkable. Either that or the lights of Paris are very bright. Okay.
Thanks, Rob. Okay, next up we have Jacob Boncoris.
Okay, here's my picture of the Hercules cluster, M13. You can also see NGC 6207 and the other galaxy IC 1617, I believe, right here. This I took last July. I was testing out my autoguide. It's 12 5-minute exposures to ISO 1600. The next one. That's my picture of the Dumbbell Nebula M27. You can see right here. Lots of stars around here, a good color. Happy with that one. The Veil Nebula here, Cadwell 33. This is taken with just my stock camera, so I was happy with the Hytchen Alpha coming in here. The Andromeda Galaxy M31. This was actually taken with 5 hours exposure in my backyard near the international airport here. So it was difficult getting rid of the light pollution. As you can see, the stars lost a lot of the star color there. Next one. And this is the North American Nebula. I took this near Charleston Lake. I was planning on getting lots of exposure that night, but was cut short by the fog, so you can see quite a bit of the noise since I was using a high ISO. Next one. This is taken in Nirvana, the Lagoon Nebula, and the Trifid Nebula. You can see I was getting good resolution that night. The seeing was good. Next one. The triangulum galaxy. You can also see another dim galaxy right here. PGC 5891, I'm pretty sure it is. The Pleiades cluster M45. This one I got in the November-December issue of Sky News. This is 2 half-hour exposures at ISO 800. Next one. This I took just last March. The Orion and Running Man Nebula. 7 10-minute exposures at ISO 1600, 7 1-minute exposures at ISO 1600, and 7 30-second exposures at ISO 1600 to get back the trapezium area.
Very impressive, Jacob, very impressive. Yes. Gordon Webster.
Okay, well, usually I do sketches, but a couple years ago somebody gave me a little Meade LPI to play with, and I occasionally play with it when I feel like torturing myself. Got this interesting shot from Brian had challenged us to look at, I can never pronounce this. Thank you. So I took this, and I was really pleased with all of the crater detail here and just all through here. Can I have the next one, please? So with Brian's help, I labeled most of the ones there, and because we're running short of time, we won't worry about labeling some of the others, but Kepler's there, or a couple other good ones. And this one, if you look closely, you can see Brian's house down here. Oh, no, back. Yeah. Brian's house down there, and he's the one with the beret and the sunglasses, not to confuse with the other ones. Okay. Next, please. NGC 2610, it's a 13 magnitude planetary nebula in Hydra. This is a sketch. You can just see it right in here. This is my 120 mil refractor at 58 times. I tried it with larger magnification and with high contrast filters, and it just disappeared. But in the what would that be, the 17 mil eyepiece, it kept popping in and out in averted vision. My copy of Sky Tool says it's not possible to see it in my 12-inch. But anyway, next please. NGC 2841 is a 10th magnitude spiral galaxy SB type in Ursa Major, and again it popped in and out with averted vision. My last one is March 11th and some sunspots. I think this is 1429 and 1430. That's right around the time we were getting bombarded with all of that solar energy. One last little note. If anybody's interested in seeing some of my terrestrial sketches, I'm having an art exhibit at Rothwell Galleries. Reception is on May 5th. Rothwell Galleries just east of Blair Road on Montreal Road. Okay, thanks.
Up next is Joe Bonner.
So, yet one more picture of the conjunction. I didn't go quite as far as the other pictures we saw to take this one. This is in St. John, New Brunswick, and that is Fort Howe. And this is a fort that was built in 1778, just after a siege in St. John during the American Revolution. And I don't believe it actually saw any action, but it was in service as far as in 1812 and a little bit later, I think. But I thought it made a nice setting for the photo. And the only real challenge I had, other than trying to figure out how to use my new camera, was trying to keep the roving bands of intoxicated teenagers out of the shot, which it seems that Fort Howe is taking a little bit of a different attraction these days than for military purposes. Next shot, please. This is the same night. This is on March 12th, and drove a little further, tried to get away from some of the lights of St. John, went into Rockwood Park. This is taken up in behind the horse barn, if those that might know Rockwood Park, and just basically pulled over to the side of one of the roads, and this tree might make a nice nice framing shot for both the conjunction of the planets and the Pleiades, and the Hyades cluster is there as well. Next one, please. And this one was taken, I believe this was just on Tuesday night this past week. It just a day early from when Venus is going to be a little bit closer to the cluster, but the weather cooperated this evening, so I went out. This one actually turned out to be a fairly short exposure. I was having trouble with the wind, so I was getting a little too much blurring
with a longer exposure. But got some pretty good color going there on the star, so I was pretty pleased with that one. That's it. Thanks.
Wonderful, Joe. Thank you. Next up is Lee.
I guess this is the March 13. We had two bright eyes in the sky. The top one is Venus, and Venus that day had just overtaken Mars, and continues to move away, to move above Mars. These are all taken from my driveway. What did I say? Mars. I meant Jupiter, sorry. And I've been hanging around in church parking lots recently at night. And this is from St. Paul's. This is from St. Paul's Anglican Church in Canada.
This is before he took the bell.
Next one, please. And again, the next night we have Jupiter beside the moon, Venus up high.
And less of the bell.
And less of the bell. It was pretty dramatic. We had some clouds come in, and they made for some very interesting pictures. Same night. Once again, same thing. And this is the stuff Norse legends are made of. Looks like the clouds are going to devour the threesome. So it made for a real nice image. I was able to borrow a 300 millimeter telephoto lens from a friend, Joe Godin. And so this shot came up. We have the moon and Jupiter. And if you look carefully, bottom left, you can see 3 of the Galilean satellites. And that's just in a normal telephoto lens. Next one, please. Once again, Venus up high with the moon this time, and Jupiter down below. This we have now the moon, nice Earth shine with Venus. And the 3 of them together, the 2 of them together with the Pleiades above. And as you can see, I'm shooting these fairly early in the evening. You can see the sky's blue, but again with the 300 millimeter lens, it would pick things up. Same one as Joe. I have a long story about this one. This was my 78th shot, and because it was windy and there was vibrations and all sorts of stuff going on. Next one, please. Again, this is the final of my steeple series. And again, Venus just leaving the Pleiades on April 4th. Yeah, thank you.
Brian McCullough.
So speaking of church shots, did anybody go to a pancake breakfast at a Baptist church on the weekend?
No.
Somebody was saying they knew, somebody said they knew me there. So this was taken with my stock camera, which after seeing Jacob's photos, Bridget says I should get rid of. All right. So anyway, so we can see, there's the moon. I think Jupiter's there, Venus is up there. My observatory down there. Bit of a closer up one, you can see there's Jupes. Here's one of my, I thought, I'll try one of these, so I did. There's the Big Dipper, right? There's the pot up there, and the handle coming, sweeping down like this, and just missing Arcturus down here. And one more. Leo, can you see Leo there? There's Mars, belly of the lion, there's the head there. I'm doing shadow puppets too, this is great. All right. That must be it.
Okay. Thanks, Brian. John Camacho.
Oh, I see Stephen McIntyre. This wasn't on our list.
Oh. An unscheduled one.
An unscheduled.
I guess that's
Don't go away.
obviously the full moon, but what I liked about it is that it was actually unusually colorful. Well, it's a moon, but you kind of use your imagination, and I didn't actually do anything in particular to create the color. I just took the picture and sharpened it up, and so there's like this sort of reddish stuff in blue, and not a planetary geologist, but I'm sure there's some significance to that. So I just a digital SLR picture through a 4-inch scope, And it's actually 4 different sets of exposures. So I took a bunch of frames and in each of the exposures and then combined them in a set of a high definition or high dynamic range picture. But anyway, so lots of detail, but it's really the color that I like. That's the February 7th full moon. Go to the next one. So we've got Copernicus. This was through the Celestron HD11 using a point grey chameleon webcam. So it's a 1-minute movie, then stacked and processed. Was there a pointer here somewhere?
Yes.
Yep. So I guess one of the interesting features is really Stadius. Stadius is this crater down there, and it's kind of an observational challenge to see it. And then the string of craters, A through W, at the top. They're actually probably, and it's my guess really, this is Copernicus here, 95 kilometers across. They're probably formed from ejecti from that hit and then spewed out over there, but they get named for that feature over there. Pixel scale is it's a half a kilometer per pixel, so I'm pretty comfortable with being able to see 1 kilometer wide features over there. There's some interesting dome features over here that doesn't quite show up on the video, but they have little tiny, like this one here, little tiny crater marks on the top of them. It was just kind of an interesting thing. So I take that picture and then I go see if I can see some of these things visually. All right, thanks.
Okay, so next few shots are from my staycation just west of Stittsville. So they're, whoops, yep, just want to point out there's M45 here, and well, you see the rest, Moon, Venus, and Jupiter at the bottom. Okay, next. I wanted to get Mars in there, but I couldn't, it was on the other side, so I got another planet, Earth, at the bottom. Okay, next. It's my neighbor's house, and of course, Moon and Jupiter and Venus.
Oh yeah, sure.
I think I'm new at this. I don't really know.
I was just thinking of what you were photographing balloons.
You would too.
I know.
So back on March 21st, Paul dragged me out to Burntlands Park, just east of Almont there. And he said, well, there's Leo, and point your camera up there. So I just take photographs with my digital SLR and a 200 millimeter zoom lens. And so there's the Leo triplets. Nice. And we go to the next one. That's zoomed in. There's your M65, M66, and NGC 3628, yeah. Okay, and then while I was doing all that, my other camera was I took 72 images, 1 minute long, 10 seconds apart, and then I used a program called Star Trails to put it all together in a stack, and that's what you get. Oh, and if you look at the bottom, there's an airplane that went across it.
So you want to get rid of that shot then?
Thank you.
Thanks, Joe. Next up is Jerry. Let me just take a second there. John, I'm expecting a presentation from you downrange a bit. John's a very modest kind of guy, saying, yeah, I took a shot with my lens, blah, blah. You have to see the barn door tracker that this gentleman built. It's like fully motorized. It's more complicated than my telescope. So I'm hoping to see a presentation with lots of pictures in the future from you and show these folks some of your handiwork.
All right, thanks, Paul.
All right, Jerry.
Is there breakfast yet? The good old Venus with the Pleiades taken from Barrhaven, a 4-second exposure, and the Starship Enterprise just going into warp. And next slide. Plato, one of my best Platos I got. The seeing was pretty transparent that night. Again, through my 10-inch Meade LX400 and TU-Cam, my course old TU-Cam. So pretty good detail on the floor. Next slide. And of course the Lunar Challenge, Aristarchus. Not easy to get because you don't want to overexpose the middle, but you want to get enough to get the outer stuff. And last but not least, oh, sorry, one more, M66. Taking one of the Meade DSI. 15-second exposures. I had about 4 of them stacked together. And last but not least, only 263 more days till Christmas. Venus just above a tree. Joe Bonner and I went to his friends just off Old Almont Road. Beautiful night sky, just fantastic. So just a Christmas tree here. Just took my cell phone just to illuminate the tree a bit and put Venus up on top. Night, folks. See you in a month.
Thanks, Gary. Okay, just a couple of quick ones. Also a bit of a impromptu observing challenge. Comet Garad is still up there. It is definitely getting fainter. For those of you that saw the image I had last month, that's far less pronounced. You can still see a tail. I don't know if you can still see it with binoculars. It's kind of touch and go, but it is fading. It is still up there, though. Next, please. And of course, I had to throw in a couple of Venus and Jupiters as well. Venus getting very close to the ground here, and you can see it was into a low cloud bank. Next one, please. Somewhat better conditions there, and you can see Jupiter with some of its moons there. And again, that's only a 200 millimeter telephoto. And the last one I got, managed to bag that supernova in M95, Bart Spiral Galaxy, and you can see the supernova is right there. So. That's a stack of 15 5-minute exposures, so I went fairly deep with it. But yeah, nice to see it. That's the second part of the observing challenge. M95 is really easy to find, and I believe that the nova is still supernova is still quite bright. So if you have an opportunity, get it while you can, because it'll. This is an 80 millimeter refractor. That's all. 80 millimeter f7.5 refractor. All right. That's it for our observations. And again, I apologize. We're running very, very late. Next slide, please. Estelle, are you here?
Yeah, I'm here.
You're okay. So Estelle's new book from us in the library there, Skywalking, an Astronaut's Memoirs. So Estelle will have the library open for you if you're interested in perusing. Oh yeah. Okay. Next one, please. Again, see Ron St. Martin if you didn't get a chance to renew your FLO key. And Ron, I'm hoping hasn't gone yet. Are you still here? Oh, good, awesome. So perhaps you could just make yourself available at the back there, Ron. That'd be great. Next, the usual. I won't go through the list there because we are running very, very late. Kelsey's for anybody that's interested in wetting their whistles or having breakfast. I think Gary expressed. Yeah, you want breakfast, right? Okay. Oh.
I called them last night. He closed at 10.
Good point.
So don't go to Kelsey's.
Don't go to Kelsey's. Okay, so get breakfast somewhere else. All right. Next slide. 88 tonight, a bit of a light turnout. I'd like to thank the people in the list there for especially supplying all those wonderful observations we had and the time spent on the presentations. Thank you very much. One more, last one. Just to remind you that the meeting in May is also a bit screwed up because it's not our usual first Friday. It is the second Friday, and hopefully I think that's the end of our foul-ups for timing. But anyway, just to remind you, so not May the 4th, but May the 11th next month. All right?
But we're trying.
We're trying. Thank you very much. Sorry to hang you up, and we will run that video. If it's like I said, it's 3 minutes. If you want to watch it, it's really fascinating. Thanks for coming, and we'll see you next month.
What the video shows is James Cameron, from the Titanic movie director, putting together the latest version of what they think actually happened during the ship's sinking. Struck the iceberg, the ship swung her stern around to try and clear. That's a normal move, but you can see how quickly the compartments are filling up with water here. He also said that he didn't think the ship actually put her stern up into the air quite as high as it showed in his movie. He said that's one of the things he would have changed. That's a terrible thing to see. As a mariner, I'm telling you right now. I don't like this. So it shows the boats being lowered there. And one of the forward funnel's going to fall away soon as it starts getting, right here, here it comes. So there goes the funnel. Now the electricians in the ship stayed at their post as long as possible to keep the lights on for people. So it's just a few minutes ride to 3,700 meters to the bottom. Funnel of boilers coming down. And the nose of the ship basically just dived down like a loon diving underwater. Look at that, that's almost 400 feet of ship there. And as the stern went down, it rotated like that, and then there's of course a lot of air being pumped up inside there, and it's blowing pieces apart. And as the ship is gaining speed, the plating just peeled away like a skin, like shingles flying off a roof.
But they didn't show
And there was,
Leonardo DiCaprio jumping off.
yeah. So a number of people got floated off as the ship went under. A number of people were still on board, riding the ship right to the bottom of the ocean. A number of people were hit by debris on the surface as the debris went up and floated up and rocketed up, like the cork life jackets, cork paneling, that shot up to the surface, and in some cases I think killed people who were already in the water. And there's the explosion of that stern section coming down like that. So the stern was a real mess. There's the bow coming up just here. And that's pretty much the way they found it. So 100 years. Thanks a lot for showing that.
Could I have a copy? I'll put it on the end.